Hello everyone and welcome to Sally and Bytes. Today, I am here to teach, using Python libraries, Part 2, for the Class 12 students of Computer Science. In this video, we are going to learn package and library, locating modules, Python standard library functions and modules, Python's built-in mathematical functions, Python's built-in string functions and practical implementation. So, let's dive in and get started. We usually organize our files in different folders and subfolders based on some criteria, so that they can be managed easily and efficiently. For example, we keep all our games in a games folder and we can even subcategorize according to the genre of the game or something like this, given in the picture. Even you can add more subfolders to the game folder. The same analogy is followed by the packages in Python. So what is a package in Python? A package is a collection of multiple Python modules organized in a directory hierarchy. Package in Python is a folder that contains various modules as files. The main purpose of a package is to create a namespace for modules, avoiding naming conflicts and providing a clear structure. A package is defined by the presence of a special file called _init _.py in its directory. The _init _.py file can be empty or contain initialization code for the package. Packages allow developers to create a logical grouping of related modules. Examples of packages in Python include NumPy, Pandas, and Matplotlib. Let's see how to create a package. Point 1. Create the directory structure. Decide on a name for your package, and then create a directory with that name. Inside the package directory, you'll have other subdirectories and Python modules. A simple package structure could look like this. Look at the right side box. Second point, add the _init _.py files. The _init _.py file is required in each directory to make it a package. You can leave it empty or add package-level initialization code if needed. This file is executed when the package or its modules are imported. Point 3. Define the modules. In this example, you have module1.py, module2.py, submodule 1.py, submodule2.py, submodule 3.py, and submodule 4.py. Each of these files represents a Python module and can contain functions, classes, or variables that you want to expose as part of your package. Point 4. Writing code in the modules. Open each module file and write the necessary Python code for the functions, classes, or variables you want to include in your package. For example, in module1.py, you might have def function _ in _ module1. Return function from module 1. Point 5. Usage. To use your package in another Python script or project, you can import the functions or classes you defined in your modules. For example, look at the right side box. Importing functions from your package. From my package.module1 import function _ in _ module1. Result equals function _ in _ module1, print, result. Remember, to access modules within subpackages, you use a similar import statement but specifying the full path to the module. That's it. You've created a basic Python package. As your package evolves, you might want to add more modules or subpackages to organize your code effectively. A package is simply a collection of similar modules, subpackages, etc. A package and a library are technically the same. Let's see an example. Let's say we have two modules named area.py, calculating area of a circle, square and rectangle, and volume.py, which has a few functions to compute volumes of the various shapes. Hence these two modules are both related to each other and should be bundled in a package. Thus, we are going to create a package geometry, which will have both modules, area.py and volume.py. Steps to create and import a package. Create a directory named geometry and add both modules area.py and volume.py in it. Also, create a file _init_.py in directory geometry. The _init_.py file is required to make Python treat the directories as containing packages. Import the package and use the attributes contained inside the package. What is _init_.py file? _init_.py is a special file in Python that is used to mark a directory as a Python package. When you create a directory and place in _init_.py file inside it, Python treats the directory as a package, allowing you to organize your code into modules within that package. Some key points of _init_.py. Package initialization. The primary purpose of _init_.py is to initialize a Python package. It can be an empty file or can contain Python code to be executed when the package is imported. Marking directories. If a directory contains an _init_.py file, Python treats that directory as a package. This means you can use the package's modules and subpackages within your code. Namespace package. In Python 3.3 and later, _init_.py is not required for regular packages and is optional. If a directory doesn't contain an _init_.py file, it will be treated as a namespace package, and its subpackages can be spread across multiple directories. Package level code. The _init_.py file allows you to define package level code, including variable definitions, function definitions, or any other initializations that you want to be executed when the package is imported. Importing modules. When you import a module from a package, Python looks for the _init_.py files in the package directories to properly initialize and set up the package namespace. What's a library? A library, in the context of programming, is a collection of code resources that provides specific functionalities. It can consist of modules and packages, along with other resources like documentation, configuration files, and data files. Libraries are designed to be reusable and are often created to solve particular problems or provide specific tools for developers. Python libraries are usually distributed in a way that allows users to import and utilize their modules and packages in their own projects. Examples of Python libraries include the standard library that comes with Python, example, math, deals with mathematical operations, OS, JSON, and external libraries like NumPy, deals with scientific computing, pandas, and requests. A package is a collection of modules, a library is a collection of packages. Multiple interrelated modules are stored in a library. And whenever we need to use a module, we import it from its library. In Python, it's a very simple job to do due to its easy syntax. We just need to use import. Importing math library. Import mathx equals 16. Print of math.sqrt of x. Output will be 4.0. Here, we imported the math library and used one of its methods, that is, sqrt, square root, without writing the actual code to calculate the square root of a number. That's how a library makes the programmer's job easier. But here we needed only the sqrt method of math library, but we imported the whole library. Instead of this, we can also import specific items from a library module. Importing specific items from a library module. From math import sqrt, sign. X equals 16, Y equals 3.14, print of, sqrt of, X, print off, sign of, y. We can see that we imported only sqrt and sign methods from the math library. Note that math library contains trigonometric functions, representation functions, logarithmic functions, angle conversion functions, etc. Advantages of libraries and packages. Reusability, save time by using pre-built code. Enhanced functionality, access a wide range of features and tools, rapid development, speed up the coding process. Community support, benefit from active user communities. Reliable solutions, well-tested and proven code. Cross-platform compatibility, works on different systems. Modularity, encourages a modular approach to programming. Extensibility, easily expand functionality with plugins. Industry standards, follow best practices for better code quality. Let's discuss about locating modules. When you import a module, the Python interpreter searches for the module in the following sequence. Current directory. Python looks for modules in the current working directory of your script or interactive session. This allows you to create and import your own modules easily. If the module isn't found, Python then searches each directory in the shell variable Python path. So, what is Python path environment variable? The Python path environment variable can be used to add custom directories to the module search path. By setting this variable, you can tell Python to search for modules in specific directories not included in the default sys.path. Finally, if all else fails, Python checks the default path, which is the location where Python has been installed on your computer screen. Python standard library functions and modules. The Python standard library is a collection of modules and packages that come bundled with the Python programming language. It provides a wide range of functionalities for tasks such as math operations, file handling, date and time manipulation, regular expressions, and more. The standard library is well documented, allowing developers to explore the available modules and functions with ease. Some of these important modules are explicitly designed to encourage and enhance the portability of Python programs, such as Math module for mathematical functions, Random module for pseudo-random number generation, and String module for string or text-related functions. Python's built-in mathematical functions. Let's discuss about the two mathematical constants pi and Euler's number. In Python, you can access two commonly used mathematical constants, pi and Euler's number, through the Math module in the Python standard library. Pi is a well-known mathematical constant, which is defined as the ratio of the circumference to the diameter of a circle, and its value is 3.141592653589793. Look at example 1. To import this single object pi from the Math module, let's see the code. Line 1, import math. We are importing the Math module. In line 3 and 4, we are importing a single object pi from the Math module and storing in a variable pi underscore value and finally printed. Now, look at example 2. Alternatively, it can be done without prefixing the module name and writing the name of the object directly after keyword import. From math import pi. Print pi. The output will be the same as example 1. Similarly, another well-known mathematical constant defined in the Math module is e. It is called Euler's number, and it is a base of the natural logarithm. Its value is 2.71828182845945. Look at example 3. These constants can be directly called and used from Math module. Note that we should remember not to use module name with imported object. If imported through from module import command, because now the imported object is part of your program's environment. In Python, the Math module provides functions to work with angles expressed in degrees and radians. You can use these functions to convert between degrees and radians or perform trigonometric operations. Math.radians of degrees. This function converts an angle from degrees to radians. It takes an angle in degrees as input and returns the corresponding angle in radians. The formula to convert an angle from degrees to radians for mathematical calculations are given on the right side of the screen for your reference. Now look at example 4. Line 1, Import Math. This line imports the math module, allowing you to use its functions later in the code. In line 3, degrees equals 45, this line creates a variable degrees and assigns it the value of 45. It represents the angle in degrees that you want to convert to radians. Line 4. Radians equals math.radians of degrees. This line uses the math.radians function from the math module to convert the angle given in degrees to radians. The math.radians function takes the angle in degrees as input and returns the corresponding angle in radians. In this case, degrees is 45, so the output radians will be approximately 0.78539816339744483 radians and finally gets printed. So, the code demonstrates how to use the math.radians function to convert an angle from degrees to radians in Python. Math.degrees of radians. This function converts an angle from radians to degrees. It takes an angle in radians as input and returns the corresponding angle in degrees. The formula to convert an angle from radians to degrees for mathematical calculations are given on the right side of the screen for your reference. Now look at example 5. Line 1, Import Math. This line imports the math module, making all the functions and constants from the math module accessible in your script. In line 3, radians equals 2. This line creates a variable radians and assigns it the value of 2. The value 2 represents an angle given in radians, which you want to convert to degrees. In line 4, degrees equals math.degrees of radians. This line uses the math.degrees function from the math module to convert the angle given in radians, stored in the radians variable, to degrees. The math.degrees function takes an angle in radians as input and returns the corresponding angle in degrees. In this case, radians is 2, so the output degrees will be approximately 114.591559026164665 degrees and finally printed. So, the code demonstrates how to use the math.degrees function to convert an angle from radians to degrees in Python. By importing the math module, you can access the degrees function and many other mathematical functions provided by Python's standard library. Python provides a wide range of built-in string functions that allow you to manipulate and work with strings effectively. Let's now see some practical implementation of most commonly used inbuilt string functions. Now, look at example 1. Write a Python function to add ing at the end of a given string. Length should be at least 3. Now, in line 4, define the function add underscore string of s with the parameter s, which represents the input string. In line 5, check if the length of the input string s is greater than or equal to 3 using the if len of s greater than 3 condition. If the length is at least 3, proceed to the next step. Otherwise, if the length is less than 3, return the original string s without any changes. In line 6, if the length is at least 3, check if the last 3 characters of the string s are ing using the slicing notation s of index of -3:. In line 7, if the last 3 characters are ing, it means the string already ends with ing, so we add ly instead. Return the modified string s plus ly. In line 9, if the last 3 characters are not ing, it means the string does not end with ing, so we add ing to the end of the string. return the modified string s plus ing. In line 11, the function has now completed, and it returns the modified string if the length of the input string was at least 3. If the length was less than 3, it returns the original string. Let's see the test cases. In line 14, add underscore string of go. The input string is go, which has a length of 2, so it does not satisfy the condition len of s greater than equal to 3. The function returns the original string go unchanged. You can check the output go on the console. In line 15, add underscore string of read. The input string is read, which has a length of 4, satisfying the condition len of s greater than 3. The last 3 characters of the string are EAD, not ING, so we add ING to the end of the string. The function returns the modified string reading. In line 16, add underscore string of exciting. The input string is exciting, which has a length of 8, satisfying the condition len of s greater than 3. The last 3 characters of the string are ing, so we add ly instead. The function returns the modified string excitingly. Example 2. Write a Python function to get a string from a given string where all occurrences of its first character char have been changed to $, except the first character char itself. Now, look at the Python code. Line 9. Change underscore char of restart. Now, look at line 5. The input string is restart. Char equals s of index 0 sets char to r, the first character of the string restart. In line 6, s equals s dot replace of char comma $, replaces all occurrences of r with $, so s becomes $ESTA$T. In line 7, s equals char plus s of 1 : concatenates r with the rest of the modified string ESTA$T. The function returns the modified string and gets printed as check the output RESTA$T. Now, look at line 10. Change underscore of char of madam. The input string is madam. Now, look at line 5. Char equals s of index 0 sets char to m, the first character of the string. In line 6, s equals s dot replace of char comma $, replaces all occurrences of m with $, so s becomes $ADA$. In line 7, s equals char plus s of index 1 : concatenates m with the rest of the modified string ADA$. In line 8, the function returns the modified string MADA$ and is printed on the console. Same way, try to work out for the string express given here. Thus, the change underscore char of is function replaces all occurrences of the first character of the input string s, except the first character itself, with $ and returns the modified string. Thanks for watching. Watch the upcoming videos. Data File Handling Part 1. Introduction of Data File Handling. Why use files, data file operations, opening and closing files? You can check the link in the description box below.